Okay, problem number 4, series problem. In my humble opinion, maybe the hardest series problem that I've seen in the last 20 years. It's got a lot going on, and the real unfortunate thing about this problem is they continue to use the same series through all 4 parts. So this is one of these problems I remember this year. If kids couldn't get the first one right, they were in big trouble. They couldn't get the rest right. It's pretty unusual for them to do this. I've never seen another problem since, I think this was like back in 2008. I haven't seen another problem since then like this, because it just messes them up in terms of their grading. A lot of people just got zeros on this one, actually. So anyway, the first thing was to write a Taylor series about x equals 0 for 2x over 1 plus x squared. You could go through the derivative process of this, which will work for the terms. It's a little hard to get a general series, and the derivatives get really weird because you got quotient rules, so it's not worth it. So I use a pre-existing series. I use the pre-existing series that kind of look like the 1 over 1 minus x idea. It's really hard to see that. I probably wouldn't have seen that at first, to be honest with you. I probably started taking the derivatives, which I did. Last time I did this problem, it got really messy. So I saw the pre-existing series. This is just a geometric series formula. You might remember that. With the first term of 1 and a common ratio of x. So it's a 1 plus x squared plus x, because first term is 1, common ratio is x, so you just keep multiplying by x, so you get x to the end. You could also do the series method for this, taking the derivative. It's not quite as bad. So then I substituted the minus x with a plus x squared. So what I did was I took a minus x squared and plugged it in for every x. So that stayed as a 1, that became a minus x squared. I'm just squaring each one of these, or multiplying that power by 2. And now it's also alternating because of the minus sign. So negative 1 to the n, x to the 2n. And then I'm going to multiply it by 2x. The next step to get to that. This is just every term multiplying by 2x. I'm going to guess a lot of you probably left this one blank. It is a very, very hard problem. I'd be pretty shocked if you saw a problem like this this year for sure. So multiply by 2x, you get 2x minus 2x cubed plus 2x to the 5th minus 2x to the 7th, or negative 1 to the n, 2 times x to the 2n plus 1. Next question says, if x equals 1, does it converge? So when x equals 1, these just becomes alternating series 2, negative 2, 2, negative 2, so it does not converge, it diverges. Not much to that one, but you have to get that problem right to get that, yeah? So hopefully now with the series, at least the next part might make a little bit of sense of what you had to do. I think these problems are pretty reasonable problems. These last two, they're a little difficult, but if you didn't get the first series, they're possible. So the next series tells you, the next problem tells you the derivative of the natural log of 1 plus x squared is our series. So they want the first 4 terms of the natural log of 1 plus x squared. So if the derivative of this is equal to that, that means the antiderivative of this is equal to that. So we're just going to take the antiderivative, we're going to integrate our last problem term by term. So I know it's on the other side, but you just take the terms from the original problem and take the antiderivatives, and you wind up with this. So really not much to that problem. It's pretty straightforward if you have the original series. And then the last problem is an error estimate. It says find a rational number a such that a minus the natural log of 5/4 is less than 1 over 100. What this is saying is a very strange way of, hey, this is my error, so this is the error estimate, right? So this is the real term, or that's the actual value, or the function we're trying to find, and that's my approximation. And they want it to be within 1 over 100. So what I did was I thought about, okay, natural log of 5/4. I have this series right here, right? Which is actually this series. But again, without the series, can't really do it. So natural log of 5/4 is the same as the natural log of 1 plus 1/4. I was just trying to write it in this form, which is 1 plus 1/2 squared. So you might remember that this is the natural log of 1 plus x squared. In this case, our x is 1/2. So what I did was I took this series, I plugged in 1/2. So 1/2 squared minus 1/2 times 1/2 to the 4th. 1/2 plus 1/3. Do I have an extra 1/2? I think I got an extra, I'm missing a 1/2 there, so that should be a 5th, I think. Hope I did that right, yeah. So that should be a 5, because 1/2 and then 1/2 fourth. Plus 1/3 times 1/2 to 6. And then I notice on this term, hey look, this is 2, 4, 8, 16, 32, 64. That's less than 100, 1 over 100. So that's my error in essence. So that term's less than 100. So the A I'm looking for is just those two numbers added together. 1/2 squared minus 1/2 to the 5th, which is 7/32. I wanted to throw this one in here just so you could see it. I wouldn't worry too much about this problem. It's a really hard problem. Although I do think, and I'm just totally guessing here, that you're going to see a series problem. I'm totally guessing. I'm thinking that under the circumstances, that the series problem will not be to this level of difficulty. They've made this nice adjustment for you, right, to cut out a lot of stuff, only give you 3 problems. So I doubt you'll see something like this. Pretty difficult.